Hello and welcome back. This is Greg French. Today we're going to be looking at the Arduino Robotics, and we're going to be incorporating the ultrasonic sensor, the HC SR04, and some continuous run servos. You can see here in the middle we've got a little prototype that my students are designing and building. They're actually going to be designing and building little hot rods and little monster trucks to run these components. And we're going to be running this through a short maze where they have to program the Arduino using C language, and it's a pretty simple little exercise, but it could be a little challenging for my high school students, but we're just getting started. So let's continue on here. You can get this little HC SR04, the ultrasonics sensor, for about $2 on eBay. I buy them probably in quantities of 10 or 20, so I get a better price, but they're only a couple of bucks. They have an effective range from about 2 centimeters to 60 centimeters, even though they advertise them out to 40. The next thing is the continuous run servo. These can be had for anywhere from around $10 on eBay. You need the continuous run servo, which has been modified so it takes the stops out so it can go further than 180 degrees, or continuous 360. They're pretty common on eBay, and again you can find them pretty readily. This is a circuit I put together in Fritzing, showing how simple this is. We've got the two servos down here at the bottom left. We have the ultrasonics in the middle, and we have a little battery pack. The reason we have the battery pack is to take the current demands off of the Arduino. So we take the red, which is the hot, and the black, which is the ground, and we run them up here to right straight into the battery. So on this little header up here, where we have the voltage down here and then the ground up here, we're running the servos directly into it instead of into the Arduino, and then we're also taking power off that header for the Arduino. You can see it's a pretty simple circuit. We've got the signal wires here in white going to the servos, and that's going to be on pins 10 and 9, and then for 12 and 11 we've got those running over here to our ultrasonic sensor. We've got the VCC, or the 5 volts, going to our header, the ground going to the header for the battery pack, and then our triggering signal is the blue line going to pin 11, and then the yellow is running over to pin 12 on our Arduino. Now I'm using the Uno, but you could use the little Nano. We've used the Nano a lot. It's a lot smaller than Uno. It's also a lot less expensive. You can get them again for a couple of bucks when you buy them in quantity. So this makes a pretty good little first robot for my robotics class, my high school class, and it's a very fun project. We're actually creating this little robot in SolidWorks. So a part of my course is devoted to a 3D modeling program called SolidWorks, which is an industry standard now for manufacturing and design, used quite extensively in industry, and now the colleges have adopted it too. Very powerful program, and most of the students like it over anything else. Here you can see it again. Even the wheels here, I've got little grooves cut into the wheels to give it a little bit better traction. But again, this was designed in SolidWorks, and then we printed out on some MakerBot and Airwolf 3D printers. This particular design has a chassis where we've put these little servo holders on the bottom here to connect to the wheels. Pretty simple design, and this is just kind of a prototype or proof of concept. Again, the kids are actually designing cars, hot rods and monster trucks and Mustangs and other things, and they're going to be incorporating this into their designs. And I'll be showing some of those on other YouTubes as we continue to advance the program to do this obstacle avoidance to get through more complicated mazes. This is a very simple maze that we created out of these Kleenex boxes. The robot has to enter one of these sides, navigate through, and come out the other side. Pretty simple little maze, but again, the kids have to program this to do that, and that becomes the challenge for them for programming. One of the problems is this particular robot is set to detect these boxes at about 40 centimeters, which is about 15 inches. So when he detects it, he ends up turning and he runs into this one. So we need to shorten that distance to probably 20 or less, so he comes up here and he's able to turn without running into this box here. But again, that's part of the challenge for the high school students to figure out, and it's a good way to teach them programming, and then where they have practical applications for running a robot. Here's a sample program for this is really for this first program that we're gonna include for the students. You can see it's titled Simple Car Program. Includes the servo library, which we're going to use to run the servos. Defining the trigger pin and the echo pin for the ultrasonics, pins 13 and 12. We're going to include the servo library. We're going to have the servo left established as one of the variables in servo right. This is the void setup. We're going to incorporate the serial output so we can actually see some output. Pin mode, trigger pin out, and then echo pin is going to be our input. So we're going to send a signal out from our ultrasonics, and then we're going to listen for that return echo on our echo pin. This will be our input. Then again, servo right is going to be on pin 9, and servo left we're going to attach to pin 10. This is our setup. Next is our void loop portion of our program. Long duration, distance, these are going to be the variables for duration and distance that we're going to use to figure out just how far away our objects are. Digital right, trigger pin low. We're going to just set that trigger pin low before we drive it high. We'll send that signal out for 10 microseconds, then we'll listen to it. We'll drive it low again, and as we're listening for it, we'll look for it on this echo pin. And if we get it, we drive that high, and then we determine what the duration of that was, and then that way we can determine the distance. The distance will equal the duration divided by 2, because it has to go out and come back, so it's traveling twice the distance, and then we're going to divide that by 29. That's the speed of sound, which is 340 meters per second, or 29 microseconds per centimeter. So this comes out in centimeters. Servo right, if we drive it at 45 or 0, we're going to get full clockwise, but we've been experimenting with different values for different speeds. Again, 80 is going to be the full counterclockwise. Here we have the distance is going to be less than 40, so when it picks up that 40, that's about 15 inches or 40 centimeters. So again, this is what we have to maybe reduce so that the robot doesn't pick the boxes up too quickly before it has to turn. It's part of the challenge of working through the maze. Servo right, okay, once we stop, we're going to stop, looks like the right servo wheel, and then we're going to drive the left wheel counterclockwise, which will make it turn either right or left depending on which servo we're driving. We're going to delay that for 2,000 milliseconds or a couple of seconds, and then we're going to stop both of these, and then we're going to go ahead and start running them again until we come up to our next obstacle. And then we go through the process again. We're going to detect the obstacle, we're going to stop, we're going to turn, and then we're going to drive it again. Pretty simple program. Down here we're showing the distance as an output on that serial monitor. And that's it. Real simple program. Somewhat challenging for high schools for their first program. High school students are getting through this pretty well. And as they understand it more and more, it becomes simpler and simpler. And then we can start increasing the complexity of the maze, where we can have them start searching for an open space before the robot even moves. That'll be in the next one. Thanks for watching this. Again, we're using the Ultrasonics HCSO4 along with a continuous run servo to drive these little prototype robots. Simple design, simple program, great starting robot for my high school kids. Again, thanks for watching. I'll see you next time.